Hello everyone, I hope all are doing fine. So in last class we have discussed about polarization of light, in which we have come to know about the Malus law, which gives the measure of the intensity of the light coming out of the polarizer or the analyzer. After the analyzer, the general expression for the intensity is this, which comes out to be converted to this I, the intensity of the light after the analyzer or a polarizer. It will be given by I naught, the intensity received by a polarizer or analyzer, after which we are calculating the intensity now. It becomes I naught times the cos square theta, where theta is the angle between polarizer and the analyzer. And if light is coming out of a polarizer, then in that case we take the average value of cos square theta, which is half. So therefore the intensity of light coming out of a polarizer, it reduces to half of the light which an unpolarized light have. So this is about Malus law. We can take few questions on this. So let us move ahead with some questions. So very first question I have taken here, it says that polarizer is used to, means we have to answer what purpose a polarizer is used to. The first option is to reduce the intensity of light, or to reduce the produced polarized light, or to increase the intensity of light, or to produce unpolarized light. So here the correct option is to produce polarized light. So polarizer, it is used to polarize the light. One thing which may confuse the students is that it reduces the intensity of the light, just as we have discussed in case of Malus law. But remember, Malus law is about the light coming out of the analyzer actually. However, it also gives the measure of the light coming out of a polarizer, which is just half, right? So which is reduced by half. But one must remember that a polarizer allows the light only in one plane without any change in the intensity of the light in that particular plane in which it allows the light. Remember this thing. So therefore it does not attribute to the change in the intensity of the light, but it produces the polarized light, or it just gives rise to the light which can have the vibration only in one plane. So because now light cannot have the vibration in all other planes, but the polarizer has not done anything adverse or negative to the intensity of the light coming through that particular plane in which the light can be polarized, or light is polarized. So therefore a polarizer just produces the polarized light. The second question is that light waves can be polarized as they are transverse wave, they are of high frequency, they are longitudinal, or they are reflected. No, all the light waves can be polarized because they are transverse in nature, right? So this is the reason for the light waves to be polarized. Question number 3 is that through which collector we can distinguish the light waves from sound waves. That means what character or what property of the light wave distinguish them from the sound waves. Whether it is interference, we have to choose the option. There can be other answers there, but we have to take one option from the availables. So it is the interference phenomena shown by the light, or refraction, polarization, or reflection. So if we concentrate on the transverse or longitudinal nature of the light, polarization is the phenomena which is shown by the transverse waves, right? So here sound wave is a longitudinal wave, whereas light waves are the transverse waves. So this due to the transverse nature of the light waves, they show the polarization. All other phenomena are shown by both the kinds, right? So it is the polarization of the light with which those light waves are different from the sound waves, because sound waves does not show polarization, because these are the longitudinal waves. We can also take a numerical question. It is, I'm taking one question just like this. There is an unpolarized light of intensity I naught. So we are given some unpolarized light having intensity I naught. It passes through 3 successive polaroids. So there are 3 polaroids, P1, P2 and P3, through which the light passes. The situation is something just like this. Polarization axis of P1, right? Or this polarization axis, it is also called as the optic axis of P1, it makes an angle 60 degree with P2 and P2 makes an angle 60 degree with P3. So this is the situation. So you can look at this diagram. So here it is the unpolarized light, here it is the polarizer. The angle between polarizer and the second polarizer P2, it is 60 degree. It is given to be 60 degree, right? So what is asked here? So this is the situation what is given. So what is asked? What is the corresponding intensity outcomes from P1, P2 and P3? I1, I2 and I3 we can name them. So we have to find out the intensity of the lights coming out of the first polarizer P1, after the second polarizer P2 and after the third polarizer P3. So let us proceed with the solution. We have to make use of the Malus law here simply. If in case of polarization the situation is about intensities, then we have to simply make use of Malus law. So the unpolarized light which is of intensity I naught, it is allowed to pass through the first polarizer P1. Then we already know the intensity reduces to half. So the maximum intensity or the intensity of an unpolarized light was I naught. So now its intensity becomes I naught by 2 because it reduces to half according to Malus law. So this is the intensity coming out, intensity, or we can say light of intensity I naught by 2 coming out of polarizer P1, first polarizer P1. Now what is the light coming out of the second polarizer P2, which is at 60 degree angle with P1? So we again make use of Malus law. So I2, the intensity after coming from polarizer P2, it is equal to I1, the intensity of the light it receives. So it is just I1. Second polarizer receives this light I1, which is just half of the intensity of unpolarized light by calculation. So the intensity after second polarizer, it will be I1 into cos square theta according to Malus law. Here theta is 60 degrees. So when we substitute the values and make calculation, we get the intensity after the second polarizer to be I naught by 8. So this is the intensity which we receive after the second polarizer P2. Similarly, we can calculate the intensity of the light coming after polarizer P3, because P3 it is lying at an angle 30 degree with P2. So we have to consider this intensity, not this one. Remember this point. You cannot just calculate the intensity by putting the intensity coming out of polarizer P1, because P3 polarizer is receiving this much amount of intensity light, intense light. So therefore the intensity coming out of the third polarizer, it will be I2 times cos square theta. Again theta here it is 30 degree, the angle between P2 and P3, and I2 is nothing but I naught by 8, the intensity which third polarizer receive. So on calculation we get this expression. So 3 I naught by 32. So this is the intensity of the light coming out of the third polarizer. So this is how we can make use of Malus law and solve such type of problems. Now let us skip to the next part of this polarization of the light. The phenomena of polarization, or we can say polarization of light, can be done in two ways also other than the method of polarizers. First one is by reflection and second one is by scattering. We will take them one by one. So here is some unpolarized light. It is allowed to incident on some medium, transparent medium, or we can say a matter at some point. Now because it is unpolarized light, so it has the components of light all over the planes. So for simplicity we are taking the two planes, one which are at some angle to the surface and other one which are represented by these dots. These represent the variation in the electric field vector in a direction perpendicular to the plane of this paper, right? So they will always remain plane, or we can say parallel to the surface. So these components which are represented by these dots, which are the component of the electric field or variation of electric field perpendicular to the paper here or screen here, so these always remain parallel to the surface. So after incident on the surface, these lights which are parallel, these components which are parallel to the surface, they are reflected back, right? And other components are refracted into the second medium. It simply means that these components which are at some angle to the surface, which are not parallel to the surface, these are completely blocked and hence they are transmitted to the second medium. and they are not reflected back. So only these components are reflected. So on reflection, we see that it is the polarized light, right? So this polarization, this reflected light ray, it will be rich in the polarization, or we can say it will be high in the polarization. This will be completely polarized if this angle is at a particular angle, or we can say this unpolarized light is incident at some particular angle of incidence, right? So in this way we can see that whenever an unpolarized light is incident on the surface of some medium, transparent medium, the reflected light ray or light waves, they will be polarized light waves, whereas the light waves which are transmitted to the medium, they will be unpolarized light waves. So that clearly explains how the light can be polarized by the phenomena of reflection of the unpolarized light. And there comes a very important law called as Brewster's law. What this law says? It simply says that at polarizing angle. So first we have to understand what is this polarizing angle. So this angle of incidence, it is called as polarizing angle when this reflected light wave is completely polarized light, plane polarized light. Understand? So when this reflected light wave is completely plane polarized, we say that this angle of incidence is nothing but polarizing angle. And this angle which this incident unpolarized light make with the surface of this medium, this is called as glancing angle. Of course, this glancing angle plus this angle of incidence both will together will be equal to 90 degree, right? So we call this angle of incidence to be the polarizing angle or angle of polarization when this reflected light wave becomes completely plane polarized. Okay, so Brewster law simply says that at this angle of incidence, whenever angle of incidence becomes equal to angle of polarization, या polarizing angle theta p, which we can write as theta p here, at that particular angle, the refractive index of this medium can be calculated by using this expression. So refractive index of the medium, it will be equal to tangent of this angle of polarization theta p. So this is a very important law about polarization by the reflection, and there comes a lot of numerical problems to solve there. So Brewster's law, let me just explain it once again. Whenever angle of incidence, when we are causing the polarization by the reflection phenomena, then this angle of incidence can be changed. Then at some particular angle of incidence called as polarizing angle, when the reflected light wave, it is completely plane polarized. There is no component of the light which is unpolarized here, right? There will be no variation in other planes other than these which are parallel to the surface. So in that situation, the refractive index of this medium can be calculated by using this formula. Refractive index of the medium, it is given by tangent of this polarizing angle theta p. So this is the Brewster's law. From here we can draw a very important result. For doing that, we use this expression of the Snell's law. We already know that when reflection, or here we are observing that reflection is taking place because light is unpolarized light and it goes to the other medium. This is also unpolarized light. So refraction is taking place. So from that we can write this result. The refractive index of the medium with respect to the first one, if first one is the air medium for example, it will be sine of angle of incidence, which is theta p here, the angle of polarization, divided by sine of angle of refraction. This is the Snell's law, and we are writing this result at this polarizing angle. Now both of these, Brewster's law and Snell's law, talk about the refractive index of the same medium. So we can equate these two, and when we equate these two, from there on the right hand side we can write it to be tan theta p to be sine theta p upon cos theta p, and when we compare or we equate these two equations, we get this expression, because sine theta p and sine theta p just cancels out from both the expressions. So we get this result, sine r is equal to sine theta p, right? Sorry, cos theta p, it is cos theta p here. So we get this result from these two expressions. So which is possible, this result is possible only when these two angles are complementary angles to each other. So therefore from this expression we conclude that this polarizing angle plus angle of refraction, the sum of these two, it will always be equal to 90 degree. And we already know that this happens only at the polarizing angle. When angle of incidence becomes equal to polarizing angle. This angle is glancing angle. You must remember the name of this angle also. Okay. Polarization of light can also be done with the phenomena of scattering. So how does that happen? So here it is unpolarized light which has the vibration over all possible directions. So it is traveling in this direction. So there is the medium through which this unpolarized light is being passed, and the particles of this medium or molecules of this medium through which it is passed should be so that the size of the molecules is very much comparable with the wavelength of this unpolarized light. Right? So whenever this condition is satisfied, the size of the particle of the medium or molecules of the medium, it should be comparable to the wavelength of the unpolarized light in order to cause the scattering of the light. So whenever scattering happens, the light waves which go perpendicular to the direction of this unpolarized light, they are completely plane polarized lights. Right? So whether along this direction or the other direction at right angles to the direction of propagation of this unpolarized light, what we see is the polarized light. Right? And at all other angles, if we see the light, it will be partially polarized. It will be polarized but not completely, it will be partially polarized. Right? So this is how the scattering of the unpolarized light also causes the polarization phenomena of the light. So we can take one numerical question here to understand the concept even with the depth. So question is that when light of a certain wavelength is incident on a plane surface. So light is being incident on a plane surface of a material at a glancing angle 30 degree. So what is a glancing angle? We just have discussed here in the Brewster's law. So this angle is glancing angle. It is given to be 30 degree. Okay. So when light of a certain wavelength is incident on a plane surface of a material at a glancing angle 30 degree, the reflected light is found to be completely plane polarized. Okay, so if at this glancing angle the reflected light is found to be completely plane polarized light, that simply means at this situation or this glancing angle, the angle of incidence is nothing but the polarizing angle. And whenever we have a polarizing angle there, we can apply the Brewster's law, right? Okay. So at 30 degree glancing angle of 30 degree means we have to calculate the polarizing angle. The reflected light is found to be completely plane polarized. So what is the question there to calculate? We have to determine the refractive index of the material. Okay. And the second thing is we have to also to calculate the angle of refraction. So how we can proceed? So because the glancing angle is 30 degree means the angle of incident, no sorry, this is not the angle of incidence but the glancing angle. So angle of incident light with the surface which is called as glancing angle, it is 30 degree. So from this diagram, if it is 30 degree, then this angle it will be equal to 90 minus 30 which will be 60 degrees simply. So it will be 90 degree minus 30 degree. So this is the we can say angle of incidence. And in this particular situation, it is given that the reflected light wave, it is completely plane polarized light. So that means this angle of 60 degree means angle of incidence of 60 degree, it is the polarizing angle. So if first part is to calculate the refractive index of the given material, then we know the Brewster's law. So Brewster's law simply says that the refractive index of the medium, it is equal to tan of theta p, the polarizing angle, which is 60 degree here. So when we substitute the value, we get the refractive index mu to be tan 60 or which is equal to under root 3. So this is the refractive index of the medium. Second part of the question is we have to find out the angle of refraction. So for angle of refraction, we already know that when polarization takes place through the phenomena of reflection, and at polarizing angle when the reflected light wave is completely plane polarized, in that case the sum of angle of refraction and the polarizing angle, this is equal to 90 degrees. So from here we can now calculate the R, because theta p it is given to be 60 degree. So from here R, the angle of refraction, it comes out to be 90 degree minus theta p. So R from here comes out to be 90 minus 60, so which is 30 degree here. So this is how we solve such type of questions based on the Brewster's law. Okay, so there are different kinds of polaroids which we see here. You can read these values here, how we understand what are polaroids, but we can also have look at the the purpose for which the polaroids or the phenomenon of polarization is used. Polaroid sunglasses, generally bright areas or where sun is quite bright, we make use of sunglasses. Polaroid filters, in order to observe the bright stars, or we can say even the sun, we can make use of polaroids in order to filter the light. For laboratory purpose also, in headlight of the automobiles, in three-dimensional motion pictures, the phenomenon of polarization is used. In window panes, you also know about it, that whenever in houses we have window panes where the inmates can look in outside in outward direction, but outsiders cannot look through these glasses inside, right? And polaroids are also used in windshields in automobiles. Okay, so these are some applications of the polarizers. So that is all about this phenomena of polarization. That's all. Thank you.